7. Today let's revise together all the eliminating second term in the grade 7 math grade 7. Now let's revise together for all some of understood for lessons in second term, and let's do some of exercises on it. Okay, first we have here lesson 1 in unit 1, powers and exponent. We know that the repeated multiplication, it's meaning exponential form. Exponent, repeated multiplication, I can replace it as an exponent. So we have here 2 times 2 times 2 times 2, it's meaning 2 power 4. 2 power 4, it's called exponential form. It's called what? Exponential form. Okay, then here I have here the number 2 is base. Okay, but the number 4 is exponent. The number 4 is exponent. Okay, yes. Now we have how can write the following number or decompose the following number by using prime numbers and write it as exponential form. I have here example 300. 300 I can decompose it into 30 times 10, but 30 and the 10 it's not a prime numbers. I can decompose other. So here 30 we have 5 times 6. 5 is prime. Make a circle on it. But 6 I can decompose to 2 times 3. 2 and 3 are prime numbers. So I have here 5 times 2 times 3. It's called 30. But here 10. It's not also prime number. I can decompose it into 2 times 5. Here is a prime number. So I have here 5 times 2 times 3 times 2 times 5. I can write 300 equal 5 times. I have here 2. It's repeated multiplication 2 times. So I can 2 power 2 times 3 times 3. Here I have 5 times 5. 5 power 2. 5 power 2 times 2 power 2 times 3. Okay, so I can write as an exponential form 300 equal 5 power 2 times 2 power 2 times 3. It's called an exponential form. Now we have here even and odd exponent of negative numbers. If you have number negative power or even, it's the same answer to the number of its additive inverse. Here therefore it's the same power even. For example, negative 3 for all power 2 equal 3 for all power 2. Okay, but note here negative 3 for all power 2 not equal to negative 3 power 2. Here I have the 3 power 2 equal 9, but negative, it's additive inverse of the 9, negative 9. But here is 9. Okay, it's this answer. But if I have here the power of odd, I can get out the negative as outside of this number. Negative 3 power 3 equal negative 3 power 3 equal negative 27. Okay, here negative 3 power 2 equal 9, but negative 3 power 2 equal negative 9. Okay, now here we have multiplication and division power with the same base. If I have the same base of the number, you can add the exponent of these two powers of the number. But if you want to divide it with the same base and different exponent, you can subtract the exponent. As an example, here we have 7 times 7 power 8 times 7 power 4 times 7 equal 7 power, the same base, 7 power 8 plus 4, 12 plus 1. Here 7, it's called 2 power 1. 8 plus 4, 12 plus 1 equals 30. But here in the division, 8 divided 6, 8 power 6 divided 8 power 4, 8 power 6 minus 4. 6 minus 4 equal 2. So 8 power 2. Okay? That's here multiplication and division with the same power. We have here 0 exponent and negative integer power. 0 exponent here, any number raised to power 0 equal 1. Any number raised to power 0 equal 1 except 0 power 0. It's unmeaning. You can understand it by using limits in secondary stages. Okay, here I have a power negative n. It's the multiplicative inverse or the reciprocal of a 1 over a power n. 1 over a power n as a positive. Okay, so here we have 3 power 1 equal 3, but 3 power negative 1, it's equal 1 over 3 power 1, 1 over 3. 3 power 2 equal 9. 3 power negative 2, it's meaning 1 over 9. 3 power 3 equal 27. 3 power negative 3, 1 over 27. Is it right? Yes. This is lesson 1. Lesson 2, it's talking about for scientific notation. Scientific notation, it's a method to write very large number or very small numbers as an exponential form. But you must to remark it. It's important remark here. The number is standard when its absolute value between 1 and 10, but it greater than or equal 1. But not equal in 10. Greater than or equal 1 and smaller than 10. Here it's absolute value. It's absolute value, mister? Yes, it's absolute value. Can I read A as a negative number? Yes. Negative 2, negative 3, negative 4.5, negative 7.68. The absolute of this number must be between 1 and 10. And you can say that A greater than or equal 1 and smaller than or equal 10. Okay? Here we have the number. And the power of 10 times 10 power, the power here belongs to z. Must be whole number as a positive or negative. For here, the example we have here the distance between the sun. We have the number 149,600,000 kilometers. I can write this number as a point. You can point that point after 1 because 1.496, it's the number between 1 and 10. 1.496 times 10 power, here 1, 2, 3, 4, 5, 6, 7, 8. So times 10 power positive 8, because when you move the decimal point from right to the left, the decimal point, the power is positive. Okay, so we have here 1.946 times 10 power 8 kilometer. It is a standard form. Another example we have here in scientific chemical, we have a new virus. The diameter length, it's called 0.00000025. So I can move the decimal point from left to the right. Here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 here because I need to number between 1 and 10. 2.5 times 10 power, excellent, negative 10. 2.5 times 10 power, negative 10 centimeter. It's the standard form. And we have here on reaching information for the 10 power negative 15, it's called Fem2. 10 power negative 12, it's called Pico. 10 power negative 9, it's called Nano. 10 power negative 6, it's Micro. 10 power negative 3, it's Milli. 10 power 0 equal 1. 10 power 3 equal Kilo. 10 power 6 Mega. 10 power 9 Giga. 10 power 12 Tera. And 10 power 15, it's called Beta. Okay? Yes. Here, how can you writing the number in scientific notation? We have here the number. Convert this number into the scientific notation. You can put the decimal point between after one digit, 8.2. So we can, here is a whole number. Move the decimal point from right to the left. So the power is excellent, positive. 1, 2, 3, 4, 5, 6, 7. So I can write 8.2 times 10 power 7. Here, the example is a standard form. Yes, here 0.00000135. You can move the decimal point to the right, from left to the right. The power is negative 1, 2, 3, 4, 5, 6. Excellent. So the number it's called 1.35 times 10 power negative 6. Very excellent. Negative 6, not positive 6, because I moved the decimal point from left to the right. Okay, here as right as a standard form. We have another examples. How can you convert the scientific notation into standard form? Write the number here 37, then without decimal point, times 10 power 5 power positive. Here I can move one digit to the right here and put 4 zeros. 1, 2, 3, 4. So the answer that will be 370,000. Okay. But here 7.38 times 10 power 3, I can write 738 without any points. Here times 10 power negative 3, 1 point here, put 0.00738. Okay, like as a standard form. Now, you can use a technology by using calculator to write the number as a calculator to find the answer, to check the answer as true. Okay, now here, operations in scientific notation. We have operation in scientific notation, operation on numbers. Scientific notation is numbers. Operation on numbers, addition, subtraction, multiplication, and division. Now, first, addition and subtraction. If you have here addition and subtraction, you must to make the power of 10 as the same number. Here, 10 power 5, 10 power 6. You can convert 5 to 6 or 6 to 5. First, you must to make 5 to 6. Add plus 1. So we must move the decimal point 1 digit to the left. Excellent. So I can write the 0.37 times 10 power 6. Mister, it's not in the standard form. Yes, true. Excellent. But here we have 0.37 times 10 power 6 plus 2.3 times 10 power 6. I have the same 10 power of the 6. So I can take the distributive property. So I can write 0.37 plus 2.3 times 10 power 6. Times 10 power 6. You can find the answer of this. Here it's called 2.67 times 10 power 6. Here it's the same of the addition. But the same number in minus, in subtraction. The easy way you can make the smaller power to the greatest power. 8 is the 9. I can write plus 1. Plus 1 here, you can move the decimal point 0.02 minus 0.02 times 10 power 9 minus 3.2 times 10 power 9. I can take 10 power 9 here, 10 power 9 as the outside of the brackets, and can write here 0.02 minus 3.2. 3.2 minus 0.02, it's equal to 3.20 minus 2 equal 3.18. Okay, so I can write here negative 2.18, negative 2.18 times 10, negative 3.18, negative 3.18 times 10 power 9 here. The answer, it will be negative 3.18 times 10 power 9. It's addition and subtraction. We have here the multiplication and division. Multiplication and division, it's easily of the addition and subtraction. Multiply the number as a decimal by the number and the exponent by exponent. Here, when we have multiplied by exponent with the same base, add the power. Excellent. So I can write 6.5 times 8 equal 6 times 8 equal 48. Half times 8 equal 4. The answer is 52. Write 52 times 10 power 4 plus 2 equals 6. It's not in scientific notation. You must to move the decimal point 1 digit to the left. So the answer, it will be 5.2 times 10 power 7. The answer is 5.2 times 10 power 7. Okay, is it clear? True. Here we have as a same for division. Divide the number by number and divide by exponent by the exponent. And when we have division, the two numbers have the same base. For the exponent, subtract the power. Subtract the power. Here we have 2.4 divided to 1.2. It's equal to 2 times 10 power. 2 times 10 power 11 minus negative 4. 11 minus negative. It's meaning extra positive. So we have here 11 positive 4 equal 50. 2 times 10 power 50. Okay, the answer, it will be 2 power 50. By the end of this example, we finished lesson 2 in unit 1. Now we have lesson 3 in unit 1, square root and cube root. You must to make the perfect square numbers and perfect cube numbers. And we can know that the perfect square number 1 power 2 equal 1, 2 power 2 4, 3 power 2 9, as the same, for example 10 power 2 equal 100. You must to also this number to recognize this number. It's important, these numbers. for the perfect square number. And here we have perfect cube number. 1 power 3 equal 1 times 1 times 1 equal 1. 2 power 3 equal 8. 3 power 3 27. 4 power 3 equal 4 times 4 times 4 64. 5 power 3 125. 6 power 3 216, and so on, as 10 power 3 equal 1. So the opposite of the power is exponent. So here we have a square root and cube root. Square root and cube root. So I can write here a square root 1 equal 1, square root 4 equal 2, square root 9 equals 3, square root 16 equal 4, square root 25 it's 5 because 5 times 5 equal 25. Excellent. Square root 36 is 6, square root 49 is 7, square root 64 is 8, square root 81 is 9, square root 10 is 1, square root 100 is 10. Okay, but here we have in the cube root 1, cube root 8, 2, cube root 27, 3, cube root 64 is equal to 4, cube root 125 is equal to 5, cube root 216 is equal to 6, cube root 343 is 7, cube root 512 is 8, cube root 729 is 9, and cube root 1000 is 10. But you must do an important note here. Cube root 0 or square root 0 equals 0. Square root 64 equal 8, but cube root 64 equal 4. It's important. The same answer, the same number, but different answer. Here is square root and the cube root. Okay. Here we have a square root negative 64. We don't have any square root is negative inside it. Square root negative inside it? No. Okay, it's undefined or meaningless. But you can down here negative outside negative square root 64. It's equal to square root 64 8, and the right negative as the same negative 8. Okay, but here in the square root only. But in cube root it's impossible. Is cube root negative 64 equal negative cube root 64 equal negative 4. Why messed up? Because here the number of the square root, any number times itself as a positive or negative is the answer, it will be positive. But here it's times itself is 3 times positive times negative equal positive times positive, positive times positive equal positive. Type negative times negative, positive times negative equal negative. Okay, as a cube root. This number for the cube root. Here, how to solve the equation? If we have sum of equations, find the value of x. Square root x plus 2 equal 4. You can put the 2 as the inverse operation here. 4 minus 2 equal 2. Square root x equal 2. So x equal 2 power 2 equal 4. But here, x power 2 plus 1 equals 17. 17 minus 1 equals 16. X power 2 equals 16. The common mistake for the students, you don't forget the positive or negative. Pay attention here. Don't forget to positive or negative if you wanted to find the value of x in the equation. The value of x, positive or negative, square root 16 equal positive or negative 4. In the power 2 only. In the power 2 only. Here. 2x power 2 minus 4 equals 46. I can put here as an inverse operation. 2x power 2 equals 50. So you must divide by 2 as both sides. Here x power 2 equals 50 divided 2 equals 25. X power 2 equals 25. So x equal excellent. Positive or negative 5. Positive or negative 5. Excellent. Here we have here. How can you solve this equation using cube root? As an example. Cube root x minus 2 equals 3. So cube root x equal 2 plus 3 equal 5. So x equal 5 power 3 equal 125. Then number 2, 3x power 3 plus 15 equal 96. So 3x power 3 equal 96 minus 15, it's equal 81. I can divisible by 3, so I wanted to find x. Here x power 3 equal 81 divided 3 equal 27. So x power 3 equal 27, x equal cube root 27, it will be 3. Excellent. Here 2x power 3 minus 5 equal negative 59. So I can found negative 5 as an inverse operation. Negative 59 positive 5 equal negative 54. 2x power 3 equal negative 54. I can divide it by 2. So the answer x power 3 equal negative 27. So the answer x equal cube root negative 27. It's called negative 3. اوعى تقول لي undefined. It's cube root, not square root. Okay? Yes. Here we finished lesson 3 and finished the unit 1. We have here unit 2. It's talking about the inequality and how to product and division the expressions. We have here inequality must be have one of these symbols, greater than, smaller than, greater than or equal, or smaller than or equal. Okay? Yes. Here first degree inequality in one variable. Okay? Yes. Properties of inequality. You can find this property as if you have here find the solution set for the inequality 3x minus 5 smaller than 1 if the substitution set is m, z or q. Here you can count negative 5 as inverse operation, so I can write here 3x smaller than 1 plus 5, 3x smaller than 1 plus 5 equals 6. I can divide by 3, so x smaller than 2. X smaller than 2. Here, then the solution set in n. The solution set in n equal the number smaller than 2, 0 and 1 only, as inside the bracket of the set. But here we have the solution set in z 2, 1. We don't have 2. Smaller than 2. 1, 0, negative 1, negative 2, negative 3, and so on. Yes, inside the brackets of the set. Here, the solution set in the Q, in the rational number. We must to write the solution set here as a set builder method. Excellent. So you can write this number x belong to x such that x belong to Q, comma x smaller than 2. X such that x belong to Q, comma x smaller than 2 inside the brackets of the set. Then the solution set in the rational number. We have here lesson 2, multiplying algebraic term by algebraic term or algebraic expression. The title is the same for the common dramas film. Yes, here we have multiplication algebraic term. If we have the same base but different power, so I can multiply the coefficient and add these two powers. So 5x power 2 plus times multiply times 3x power 1. So 5 times 3 equals 15. X power 2 plus 1 equals 3. 15x power 3. 15x power 3. Here we have multiplication and the algebraic expression. We have here preload as example. If the length of the rectangle exceeds the width by 3, the length of the rectangle exceeds by the width as 3. Suppose the width as x, so the length is x plus 3. Okay? Okay, true. Here, of the rectangle equal x. What is the area of the rectangle which Hamza and Alia followed by the correct? So we have multiply x times x power 3, x times x equal x power 2, x times 3 equals 3x, not 3. 3x. So x power 2 plus 3x as the area of it. It's true for the Alia, wrong for the Hamza's solution. Okay? Now we have lesson 3, multiplying algebraic expression. Multiplying algebraic expression. Here we have these two expressions consist of more than one term. And if we have consist of two terms, it's called binomial. But if they consist of three terms, it's called trinomial. And more than three terms, it's called polynomial. Here we have multiply binomial by another binomial. Here, so you must to make the distributed x times x, x times b, a times x, a times b. Okay, distribute this time. And I can take the common as x, so we have here x power 2 plus a plus b x plus ab. Okay, as example here. Here x plus 2 times x plus 3. X plus 3 times x plus 2. X times x, x power 2. X times 2 equal to x. 3 times x equals 3x. 3 times 2 equal 6. So I can here 2x plus 3x equal 5x. So x power 2 plus 5x plus 6. It's this example, and you can find by the model of the squares. You can make the here by inspections. Okay, as examples, or you can make vertical method as the same answer. Here we have a special case of the numbers, special cases of the number of multiplying binomial. We have the first special case, it's called expansion of the square of binomial. Perfect square numbers. We have x positive or negative, p power 2 for all power 2. I can take the first term power 2. Here, the second term, power 2. The twice of the product of these two terms, a times b times 2, 2ab. A power 2, b power 2, 2ab. A times b times 2, 2ab. Okay? It's the perfect square numbers. Here, the second one, the product of sum of two terms by the difference of this it's two terms. We have the second special case, it's called difference square. Difference square. So we have here, if the same two terms we have between of them adding and subtracting, so I can take the first term power 2 and minus difference square minus the second term of the power 2 of the second term. Okay, here's as the same example, x plus 3 times x minus 3. I can take x power 2 minus 3 power 2 equal x power 2 minus 9. The answer. Okay, that's the special case for multiplying binomial by binomial. Then another title, we have multiplying a binomial by algebraic expression consists of more than two terms as a trinomial, polynomial, and so on. Okay, we have here x minus 2 times x power 2 minus 3x plus 5. Yes, it's the same using the distributive. X times x, x times x power 2 equal x power 3. X times 3, negative 3x, negative 3x power 2, x times 5, 5x. Okay, here negative 2 times x power 2, negative 2x power 2. Negative 2 times 3x, negative 6, negative times negative, positive, positive 6x. Negative 2 times 5, negative 10. So I can write here x power 3, negative 3x power 2, negative 2x power 2, negative 5x power 2. 5 plus 6 equal positive 11x. Here, negative 10. So the answer will be x power 3, negative 5x power 2 plus 11x minus 10. Okay? Yes. This answer of the multiplying binomial by another algebraic expression as a polynomial by the end of this series. So now we have lesson 4 in unit 2, dividing an algebraic term or an algebraic expression by algebraic term. So I can abbreviate this title, dividing by algebraic term. It's the easy lesson. The opposite of multiplication is division. We can, if we have this two term divided by term as the same of the base, so divide the quotient and subtract the exponent. The lesson 2, multiply the quotient and add the exponent. If we have here times, but here if we have divide, here divide the quotient and subtract the exponent. So negative 14 divided 2 equal negative 7. X power 6 minus 2 equal 4. Negative 7x power 4. Okay? Here, but if I have the algebraic expression, I can take A divided C as a one term plus B divided C as a second term. A divided C as a first term minus B over C as a second term. Okay? Yes. We have here another examples. 10x power 2 plus 8x divided by 2x. 10 divided 2 equal 5. X power 2 divided x power 2 minus 1 equal 1. X. 5x. Here a divided 2 equal 4. X cancelled by x. So we have here 5x plus 4. Another example here, 9x power 3 minus 6x power 2 is algebraic expression, consists of two terms, binomial, divided by term 3x. 9 divided 3 equals 3. X power 3 divided x equal x power 2. 3x power 2 as the first term. And minus here, minus 6 divided 3 equal 2. 2 x power 2 divided x equal x power 1 x. So we have here 3x power 2 minus 2x. Okay, that's dividing by algebraic expression, by algebraic term. We have here preload example. Both Summer and Anas find the quotient of this number. Let's say the answer of the Summer and Anas. Summer say that 4x power 2 divided negative 2x equal negative 2x. 4 divided negative 2 equal negative 2. X power 2 divided x equal x. It's excellent. Here we have negative 6 divided negative 2 equal positive 3. X divided x equal 3. So negative 2x plus 3. The answer is true. Here the answer is true. Anas, we have here Anas negative 2x minus 3. Oh. Here, which is true? Excellent. Anas is true because here the expression here positive 2 here. Summer is true, but Anas is false. Here negative divided negative equal positive, but here negative divided negative equal negative. No, there's two expressions. So we have here plus. The answer is wrong for the Anas. We must to make the addition, not subtraction. By the end of this exercise, we finished lesson 4 dividing by algebraic term. Now we have lesson 5 divided by algebraic expression. If we have expression by expression, you must to recognize or remember for the long division you understood from grade 4, 5 and 6. Yes, but here in the algebraic expressions, not in numbers, in algebraic expression. Here we have dividend, dividend, here divisor, and here quotient. How can find with this? If we have x power 2 minus x minus 20 divided by x minus 5, take the first term from the left by the first term from the left of the dividend divided by divisor. X power 2 divided x, I can write x. Okay, x times x equal x power 2. X times negative 5, negative 5x. Okay, so I can here make the subtraction. Minus x power 2 minus x power 2, cancel it. Here, negative x minus negative 5. Negative, it's meaning positive. Yes, negative and negative, it's meaning positive. So I have here negative x, positive 5 equal 4x. 4x and drop negative 20. We have divided times minus and drop. Yes, 4x minus 20. Repeated the steps again. Here 4x divided x equal 4. Right, for the quotient. 4 times x equal 4x. 4 times negative 5 equal negative 20. So I can subtract of them. Here, this term, as the same like for this term, you can subtract it by cancel this term, it will be 0. So the answer it will be x plus 4. So if I have the algebraic expression, x power 2 minus x minus 20 divided x minus 5 equal x plus 4. You can check the answer by multiply x plus 4 times x minus 5 as a lesson 3 multiplying algebraic expression. Excellent. Here, it's this, remember to divide it by steps by the number. Divide times subtract and bring down is drop. Divided times minus drop. Okay. Now we finished lesson 5 in unit 2, and by the end of this finish unit 2, we finished the first branch. It's called algebra. Now take the together unit 3, summary of unit 3. Lesson 1, it's called area. What is the meaning of area? Area, it's the number of the covered surface squared inside the shape. We know that the area of a square from grade 3, when I was a child, here, the area of a square, side times side, or side power 2 as a grade 6 for the exponential. Side times itself or side power 2. But the perimeter, side plus side plus side plus side. Perimeter of any shape, sum of all side lengths. Sum of all side lengths. You can find the total of all side lengths. This perimeter. But area, I need the title, the important title for this lesson. Area. Area of a square, side times side. Side power 2. Area of rectangle, length times width. Area of rectangle, length times width. Area of parallelogram, base times height, or base 2 times height 2 if I have here the height here, okay? Base times height or base times height, okay? Yes, that area. But perimeter, base 1 plus base 2 times 2, the same here, length plus width times 2, okay? This parallelogram. What about for the area of rhombus? Area of the rhombus, side length times height. Side length times height. Okay? Because here all side lengths are equal. Here the height equals this height. Equals this height. Equals this height. Okay? Yes. Side length times height. But area of triangle, half times base times height. Area of the triangle equal half times base times corresponding height. Half times base times height. Okay? And we know that the perimeter of any shape, sum of all side lengths. Area, half of the area of rhombus or area of a square. Half times the product of its diagonals. Half times product of its diagonals. What is the meaning of diagonal? We can remember that from the first term, the diagonal, it's the line segment joined by two non-adjacent vertices. Bravo. Here from A to C, it's called diagonal. And another here from B to D, it's called another diagonal. Any quadrilateral has only two diagonals. Any quadrilateral has parallelogram, rhombus, square, trapezium, kite, rectangle, all of them has two diagonals. But I need here the area of rhombus and the area of square only. Why must I by its diagonals the rhombus and the square only? Because the diagonals are perpendicular and I can divide this diagonal or square into two triangles. Here I have base and height. Half times base times half height. Half times base times half height. Here half diagonal. We can find the total of them. It's equal half times diagonal 1 times diagonal 2. And by using diagonals, half times diagonal 1 times diagonal 2. Again, area of the rhombus, half times diagonal 1 times diagonal 2. Here, those two diagonals are not equal in length, but the square are equal in length. From the cases of special cases for the square, the two diagonals are perpendicular and equal in length as a square. So I can write half times d or half times d power 2. Area of rhombus, half times d1 times d2. Here, half times d power 2. Half times d power 2. You can find as this model to find the area. It's half d here. That's half d. Take this triangle by this triangle and this triangle by this triangle. We have the greater rectangle. We have half d, half d. So I have here d. Okay, and we have another here this side half d. So I can area of the rectangle length times width. Half d times d equal half d power 2. Half times d times d equal half times d power 2. What about for the area of trapezium? Area of trapezium, we took it from grade 6. We have here sum of bases. Sum of two bases. Sum of two bases is here, base 1 and base 2 are the parallel. If I found sum of two bases and take the average of them or the divided by 2 of them or mean of them, it's called middle base. It's called what? Middle base or average base. Middle base times height. The area of trapezium, the length of middle base times height. Length of middle base times height, or half times sum of two bases times height. Half times sum of two bases times height. You can replace this part, half times sum of two bases. It's called middle base. Middle base times height. By the end of this area of trapezium, we finished lesson 1 area in geometry. Now we have lesson 2 geometric constructions. It's this all of the lesson how to draw by using compass, ruler, and pencil. Don't draw by using your pen. It's important note. don't draw without using ruler or compass, or you must to construct the compass as perfect to make the up and down clearly. Okay? Yes. Here we have the first bisecting an angle. Bisecting an angle, we have here make an angle as a given measuring unit. Here is I have here obtuse angle by using protractor. Make the angle. How to bisect this angle? Make the compass here and make an arc. Arc from the vertex P. Make an arc. Intersect the ray of AB and intersect the ray of BC. And start the compass from A by giving and then open the compass. Yes, and don't close this hole. Don't close this hole. This hole is important to make here arc, and the same hole for an arc from D. Arc from A, arc from D. To make the here construct these two arc and using ruler to join B and D ray. So here, if you want to check your answer, you can use the protractor. Here, this angle equals the measure of this. It's called bisecting an angle. Okay. Here we have bisecting a line segment. How to bisect a line segment? Draw a line segment as a given length and start from open the hole in the compass A, arc up, arc down, arc up, arc down. Yes, and the same hole from B, arc up, arc down, arc up, arc down, and you can join these 2 points, 2 intersecting points of the arcs here by straight line. It's meaning the bisect of the line segment. Here you can measure this by using ruler. It's equal to this part. This part AE equals the part EB. AE equals the part of AB. Here the second drawing a line segment, bisecting a line segment. The third one, here drawing a triangle. Drawing a triangle can divide it into 3 parts. How to draw the triangle? By giving measuring of the 2 angles and the length of the side drawing between their vertices. I have here line segment AB 4 cm. 4 cm, and you can use by protractor here the angle 50. Make the ray. Okay, here I have a given with angle 45. Another make a ray from B. Measure of angle A, measure of angle B, and between of them the length of the sides. Okay, 4 cm. Here these 2 rays intersect at one point. This is the third letter of the triangle. So we have here the triangle. ABC was given the 2 angles and length of its side between all them. The second, how can drawing the triangle with given length of its sides? As we took it from the first term. Yes, here we have, if we have here, draw the triangle 5, 4, and 3. So take the greatest length, make the horizontal line AB 5 cm. Open the compass as from 0 to 3 by ruler, with the ruler. Make from B here 5 cm, 4 cm. And from A 3 cm. 3 cm, and from B 4 cm. Here we have the point, intersection point between of them. You can using the ruler to join this point and this point to make the rectangle 3, 4, and 5. Is it clear? Yes, excellent. We have another third, how to draw the triangle with given lengths of its sides and measure of included angle between them. I have these 2 sides and the included angle between of them. I have the side given, the side is given, and between the angle of them have a given also. We can write 4 cm as a given and make the angle 65A as a given, make the ray, and the AC, it's called 3 cm. Open the compass 3 cm from A, make arc. Arc intersect this ray, and you can join to the another point. So we have here 3 and 4, and between of them 65 degrees. Okay? Yes, that's called of this triangle. By the end of this drawing triangle, we finished lesson 2, geometric construction in geometry. Now let's study lesson 3 in unit 3. We have geometrical transformation. Geometrical transformation can divide into 3 important subtitles. We can define it as reflection, yes, translation, and the last title it's called rotation. Yes, reflection, translation, rotation, as you know, and all the around this term. We have here reflection reflection, it is the same for the mirror. You can this shape reflects by another shape. We have a line symmetry between them. Line symmetry between them. It's called reflection line. But here translation. This shape move by the same direction into this point. This point move to this point. This point move to this point. This point move to this point. As the same for the shape, it's move from a space to the another space. Okay. Here rotation, I can round this rotation by clockwise or counterclockwise. Counterclockwise with a positive, clockwise with a negative. Let's study together here. Revise on it here how to reflexing or reflex the point around in x-axis and in y-axis. In x-axis you make the same x coordinate as the same, but change the additive inverse of the y-axis. So we have here x and the negative y. The xy reflection by x-axis, it's equal to x and the negative y. But reflection on y-axis, negative x and y. Yeah, the same of y coordinate by change the sign of the x coordinate. Okay? Yes. But in translation here from xy by translation to ab, so I can write x to be x plus a, y plus b. Okay? Here a to be a dash is the image here by translation from a to b. Okay? Yes. And rotation with anti-clockwise by the positive direction. Here with a clockwise by the negative direction. Counterclockwise positive, with clockwise negative. With clockwise negative. With counterclockwise positive. Okay? Yes. Here by inspections. And note we have here the center of rotation. We have center of the rotation, the point, center point. Okay. Measure of an angle rotation, measure of an angle rotation, and here direction of the rotation. Direction of the rotation are from clockwise and negative and anti-clockwise. You can write the measure of an angle rotation here. If the anti-clockwise, I can write the theta is positive, but the clockwise, the theta is negative. Oh, Mister, I remember you, some of words of you. We don't have any angle is negative, but here the angle is negative. Yes, it's negative by in the direction. And the direction, not in the value. Not in value or magnitudes. Okay? Negative, it's the meaning in direction to the clockwise. Okay? This lesson 3. And we have here lesson 4, composite of the geometric transformations. We have here composite of the two reflections. Draw triangle A dash B dash C dash is the image of the triangle AB by reflection on the x-axis. Then draw the triangle A double dash B double dash C double dash as the image of the triangle A dash B dash C dash by reflection on the y-axis, or followed by y-axis. So we have here A, B, C. Write the points. We have here the points A, B, C. It's given. Here reflection on the x-axis make the x as the same 1, 4, 3. 1, 4, 2 as the same, but here 1, negative 1, 3, negative 3, 4, negative 4. Here A dash, B dash, C dash. Followed by the reflection on y-axis, make this y as the same, negative 1, negative 3, negative 4, and here 1, negative 1, negative 4, negative 4, 2, negative 2. So I can represent these points A, B, C, make the join this triangle A dash, B dash, C dash, and A double dash, B double dash, C double dash as its coordinates. Here A, B, C, A dash, B dash, C dash, and A double dash, B double dash, C double dash. It's drawing. It's a very important exercise to found it for any test, for any summative test. Okay? Yes. Composite of the two translations. We have here draw ABC here with going point, then draw it by image translation -2, 1. So I can here by translation -2, 1, -2 plus -2, -4. Here -1 plus 1 equals 0. So we have here A dash 4 0. B dash 3 and the -2, 3 plus -2, 1. 0 plus 1 equal 1. 1, 1 is B dash. Here we have C dash 2 plus -2 equals 0. 4 plus 1 equals 5. So I have here A dash, B dash, C dash, and I can follow by translation 0, -5. The A dash, B dash, C dash I can translate into by 0, -5. 0 is the same number, -4, 1, 0. But here 0 plus -5, -5. 1 plus -5, -4. 5 plus -5, 0. So I have here A dash, B double dash, C double dash اللي هي O here, or O. O, it's in the meaning C double dash. O is the origin point, yes. Here, I can found this example to draw it as this coordinates at A, B, C, A dash, B dash, C dash, and A double dash, B double dash, C double dash, it's the origin point. It's called the translation. Translation as the same direction. E, 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 E. Okay? Yes. Here we have composite of the rotation. Draw the image of A, B, C under the rotation 0 and 90. 90 here is positive, so I can move counterclockwise. Counterclockwise by rotation A, B, C. Here the point by O and 90. Around from O 0 here and 90. T. X, Y, Y, and negative X. Negative Y and X. X, Y, negative Y and X. X, Y, I can rotate negative Y and X. Negative 1 and negative 4. Negative 1 and negative 1. Negative 3 and negative 2. The rotation by O and 90. But the rotation by O and 180, here we have X, Y the same for negative X. Negative, rotation 180 for A dash, followed. I need to follow the rotation here. Negative X, negative Y. Negative X, negative Y. Negative 1, negative 4 as a 1 4. Negative 1, negative 1, 1 1. Negative 0, negative 2, 0 2. So I can draw it here A, B, C and A dash, B dash, C dash as its coordinates. Here the A, B, C and rotate it A dash, B dash, C dash. Here rotation by 90 degree here from second to third, 90 degree. Here with anti-clockwise here and another rotation for this by 180, the semicircle 180 with 0 180 fold. Okay, by the end of this rotation I finished lesson 4 in unit 3 and I finished the second branch, it's geometry. Now the summary of unit 4. The summary of unit 4, we have 2 lessons for unit 4. It's called probability. It's a small branch of the statistics and easily from the statistics. Probability, we have here random, experiment, sample space and events. If I have here, I can found the random symbol. Here you have here 4 cards. Number from 1 to 2. Here 4 cards are all bearing from the here it's the random experiment. 1 2 3 4 random. You can the random choice. Okay, but here if I have 1 1 1 1, the answer will be 1. If I close my eye, the answer will be for anyone is 1. It's not a random experiment. Here we have don't random experiment with all of the cards are empty or all the same color. It's not random experiment. So the random experiment you can choose randomly. Okay, we have here the common example. Toss. Toss have a coin head and tail. Head and tail. This called head and this called tail. As a simple like this. Yes. Okay. We have here head. It's image and tail. It's written. Okay. I can abbreviate by H and T. If I took the coin 1. The sample space for all of the probability of the choice. I can the answer appear head or tail. We don't have another third solution, head or tail. So I can write as is said. It's called sample space. Here another common example: dice or die. Die. If I roll dice 1, we have 6 probability. 1, 2, 3, 4, 5, 6. Have another number? No. The numbers from the dice from 1 to 6. This is called sample space. Sample space. Yes. Here events, the subset of the sample space. Events, it's a possible number of the sample space. Here we have a preload example. If a fair die rolled once, the number appearing on the upper face is observed right. Is observed. Okay? Write the sample space first, and then determine each of the following events, indicating which of them is simple, certain, or impossible. Simple, certain, or impossible. Here we have the sample space. Here's all the dice from 1 to 6. We know that. Here the events of events A obtaining an even number from this number 2, 4, 6. Write this event A. It's the here as a set of 2, 4, 6. Event B as obtaining numbers greater than 1, 2, 3, 4, 5, 6. Here event C is obtaining an even prime number, only 2. Here we have event D obtaining number less than 6. All of them less than 6 is a sample space. Here event E is obtaining the number 8. I have number 8 in the sample space? No, the answer it will be 5. Don't write 8, 5, because we have the substitution set for the sample space. It's called from 1 to 6. Here simple even the number only one term here, but here all of the term it's called certain even. Impossible even is a 5. Impossible even is a 5. So the answer, the choice choose the correct answer. The impossible even is 0, 1, 2, 5. 5. Yes. The certain even, the probability of the certain even is the same. The probability of the simple even, it's even or number of events or number of all terms of the sample space. Okay, that's our lesson, the second lesson, lesson 2, theoretical and experimental probability. Theoretical or experimental probability. Probability of impossible even is 0. Important notes. Important notes. Probability of certain even is 1. Any number over the same number is 1. Certain even, I have all of the term in the simple space. Over the simple space equal 1. Yes, probability of any possible number between 0 and 1. Probability any number between 0 or 1. Not smaller than 0 or not greater than 1. It's equal to 1, certain even. It's equal to 0, impossible even. As in here an example. Here we have take by the last example here for this booklet here. Okay. Here I have this example theoretical bound. Yes. And even get on odd numbers and even numbers by this dice. You can solve it by yourself. By the end of this lesson, we finish the revision for the all of lessons on the second term. بالتوفيق إن شاء الله أبناء الطلاب، كل عام وحضراتكم بخير. Thank you very much. Don't forget to like this video and subscribe for the channel of Emmy.